Hello and welcome to this video on how to do rice or ice calculations, and this is for year 2 A-level equilibria. So these are KC calculations with a couple of extra steps in them. The KC calculations that you might have done before, where you're given equilibrium moles for everything in the reaction, you just plug those into the KC expression, raise them to the power of the number of moles, and that will give you your value for KC. With these rice or ice calculations, we're given two initial moles, so initial moles of two things in a reaction, and we're given one lot of equilibrium moles for one thing in the reaction, and then we have to figure out the equilibrium moles from those values. So first, under the question, let's draw out our rice table. So I'm going to write down the word rice down the left hand side, and we need to know what it stands for. So R is for reaction, I is for initial moles, so moles at the start of the reaction, C is for the change in moles, and E is for the moles at equilibrium. So we've got our balanced equation up here. Just for the purpose of this video, I'm going to write it out again here in this row for reaction. Next, I'm going to look at the question and fill in the rice table from that. So it says we've got 0.46 moles of carbon monoxide mixed with 0.45 moles of nitric oxide. These are our initial moles because they're the moles that are mixed together at the start of the reaction. So we can pop those numbers into our table. You don't need to times or do anything with them. Now for products, at the start of any reaction, the moles of products are 0. This is at the very start, they've not had a chance to form yet. And we've got some moles at equilibrium for the nitric oxide. So let's go to our equilibrium row under nitric oxide and write that value in, 0.25. So if we look at what we've got, we can see we've got two values for the nitric oxide. That's going to be our starting point. If we subtract 0.45 minus 0.25, we can get our change in moles. Now the change in moles, we use the ratios from the balanced equation to get the change for everything else. You can see we've got 2 to 2 of these two reactants. The ratio is the same, so the change will be the same. Same thing's happening here, 2 to 2, change will be the same. And for this product, it's a 2 to 1, so we divide our change by 2 to get 0.1. Now our changes for reactants, our reactants are being used up. So we're going to pop a minus in front of these because our reactants are being used. And our products are being formed, so we're going to put a positive in front of the change for the products. Now we're able to work out our equilibrium moles by doing a sum. So for the reactants, it would be 0.46, the initial moles minus the change. So 0.46 minus 0.2, and we get 0.26. For the products, initial moles plus the value of the change. So 0 plus 0.2, and for this one, 0 plus 0.1. And now we're ready to write our KC expression and plug in these equilibrium values. So remember, KC is products over reactants. Pop our numbers in. So that's our value for CO2 times the nitrogen over the reactants So if we've got 2 moles of it, that becomes a squared, raised to the power 2. Now let's work out a value for Kc, 0.95 to two significant figures. So to work out units, I've collected them together. We've got one more concentration term on the bottom compared to the top. So we've got 3 on the top, 4 on the bottom. That means we end up with This cancelling with 3 of those, which leaves us 1 concentration term on the bottom left over. So when it's on the bottom, it's moles dm minus 3. But when we move it to the top, we change its signs. So moles plus 1 becomes moles minus 1. dm minus 3 becomes dm plus 3. And this value of Kc is slightly less than 1, and that's telling us something about the position of equilibrium, that it's slightly towards the reactant side. Thanks for watching. I hope this video was helpful. If it was, please like and subscribe.